Hello guys and welcome back. So I have the sim done and I've got 150 frames and you can see the size here went up to 10 megabytes and it's 3.3 gigabytes for this simple sim. So I'm going to create a file node, and what I'd like to do when I have this kind of setup, I like to copy the path, the output path, create a file and do this. Now we have the sim. Let's take a look. Hit play. It's reading from disk, and we have the two impacts. Cool. Let's copy the group. Blast that removes the group, and I just need this bottom part here. And they have velocity. They have everything on them, of course. So what I want to do is I want to create a second sim. So top network. And I want to use or create a sim from these guys. Okay, let's say you have the impact and then you have the dust traveling through the ground or something, and it's kicking up some more dust going upward, or some kind of magic or anything. The idea is very powerful, and hopefully you guys can come up with something to use this technique for. So okay, so this is the frame. Let's say it starts at 36. I'm gonna go under sim, change the start frame to 35. Just add a frame ahead. I'm gonna change this to 35 so I don't have to wait for all those guys. And I'm gonna copy the ground because I want to respect that. So let's copy it with the merge node, and let's maybe copy the force, the gravity as well. And let's dive inside and delete this. This is cool. Okay. And set this to 2000. I'm gonna turn off display proxy mesh. I don't need to see it. And I need to tell it to emit from all points. Okay. And it's emitting from all the points, and the result is quite heavy because there is a lot of points coming in every frame. How much do we have now? 200,000. So an easy way, quick and easy way to make this lower. See this? There's this ID here. First of all, I'm gonna clean this data up and save it to disk because I don't want to keep streaming the high-res cache and just using a portion of it. So I'm gonna create a group delete all the groups. I don't need anything, I think, for now. Yep. And then I'm going to delete the attributes that I don't need, and that's going to be everything except the I don't need the color anymore, so I'm gonna leave V and ID. That's it. And P, of course, which is left. And let's copy this path. Call this ground, or just collided. 150 frames. Save to disk. Shouldn't take too long. And this way we don't have to worry about anything else streaming in, or we don't have to pay for any overhead. And the idea is I want to reduce the point count so that I can do faster iteration over the sim, and then when I'm happy with the result I can turn on the high-res version. So right now this is our high-res emission. We don't have any other source. Okay, and I'm going to create a wrangle node. I'm going to use the ID attribute, which is a unique number per point. I'm going to generate a random. It's f equal random test, and it's equal rand of ID, and this is going to generate a value that goes between 0 and 1 based on the ID number. So let's take a look. And let's split this top and bottom. GeoNode. Okay, so we have the random. You see it goes between 0 and 1 based on the ID. And what we can do, because we know this value, it goes only between 0 and 1, there is a 50% chance that 50% of the points have a value of 0.5. And there is an 80% chance that 80% of the points have a value of less than 0.8. That's how it works. The distribution is the percentage is pretty good with this random function. So what we can do is, I'm not going to store it here. I don't care about storing it. I can say if my random value, the result, is less than 0.8. Okay, if this random value result is less than 0.8, I want to delete the point. So remove point from where? From input number 0. What's the point number at ptnum? Okay, and now we have 20% left of these points. See, 16,000. I'm gonna say 0.9 here, and we should see exactly 10% left, approximately. Okay, so we can easily reduce the number of points, and this will work, trust me. Okay, let's give these guys a color so we can see them nicely. And let's dive inside. And it's still caching the old result, so let's go back up and reset the cache. Sometimes it doesn't notice that the input changed or some attribute changed that it needs to recook, and we're going to do that. And for now, Houdini is freezing, so let's hope it comes back. Okay, cool. And I didn't realize this. I want to save some space. Cool, I'm gonna hide this as well. That. Okay, let's go back to the object. O is the shortcut to open this browser if you lost where you are in the graph. And let's hit reset. Let's dive back in. And let's hit play. Cool. That's our blue points coming from the source. And you can see some of them have velocity pointing upward. That's because they are trying to bounce, or they have velocity pointing that direction. So I'm gonna increase the velocity a bit, add a little bit of randomization here, and I'm gonna add a pop force. I'm gonna add some force to them, some noise to them. Let's hit play. Cool. Let's add more randomization. I want more breakup in the force. And I'm gonna give it a stronger velocity on the y-axis. Actually, let's set it to 3 on the y-axis. Cool. So this is one pass that we could add to enhance the visual of the previous pass. The force is not very strong. The noise I'm not seeing too much, so I want to increase that. It's too much. Let's increase the size to 4 and this to 20. Cool. And let's make them die as well. I don't want them to live forever. So 1 with a threshold of 0.1. And those are still colliding. So let's say 2. Cool, something like that. And we can now merge this effects. Where is it? Let me copy the dop import from the previous one and paste it here. Let's drag and drop this guy, and now we have a second effects. I'm gonna control click on the original pass, and I think the velocity is now much faster. The second one, it looks cool. Looks cool, but it's too fast, and we can obviously tweak that. So let's make sure we have some gravity first. We have that. We have the ground. We can add some friction to the ground. So right now the friction is set to 1, and in the solver, if we go under updates, we have to make sure, where is it? I think it's on by default. Yeah, so in the pop object, the friction is not on by default, so we need to set this to a value so it drags the points or causes them to lose energy. And let's reduce the inherited velocity to 10 times. I want them to drag behind the original one, but I want them to have a force to push them upward. Yeah, something like that. It's like a trail from the source, but it goes up. And I think I'm gonna lower this. And again, you see that I'm not doing anything new here. I'm just tweaking the noises, and again, there's not a lot, to be honest, that I can share. It's just the most important part is the setup, and most of the time you spend 20%, 10% tweaking, setting up the setup, and then a lot of time tweaking it. So this is the idea that I was trying to create, something that goes upward and it lingers behind the effects, some kind of trail. Cool. Yeah, something like that. So let's add it back and see how it looks with this. So let me control click there. And they are on top of each other right now. So let's change the view to pixel, see if we can get a better view of what's happening. And it's very important to view this in real time. So let's do this. I'm going to turn off the emission, the random thing that deletes 80%. I'm going to leave the original. I'm going to right click and here, right click, and I'm going to run it for 150 frames. Increase the viewport sampling by pressing the D, increasing the AA, so it gives us back finer pixels. And let's hit play. I may have to pause for this. And again, with this splash, see those first frames, it's going to be so much motion blur that we're not going to be able to read the points. It's going to create some kind of streaks, and that's very believable, and it looks really cool when properly lit and rendered, and you have enough resolution in the details. Now, one thing I don't like here is, see this blob here. I like to break this up with more noise and simply improve the overall look of the behavior and the particles. Okay, that's the second effect there going. And as they collide, they will cause more particle to come up, which could be very interesting, and it will add more layering to this. Okay, now one more thing. I like this. I mean, it still needs a lot more tweaking, probably increase the point count for this pass a lot as well, 10 times more. What I'd like to do is I want to add a drag on these guys to calm them down a bit. but let's wait for it. And see, this behavior may not be a realistic element when it comes to dust and things like that, but if you have a magical impact, which is the first idea that we had, was to have a magic trail shooting, hitting the ground and then opening a portal, and all this it's sci-fi and it's magical. There's nothing realistic about it. So having these kind of cool elements could actually help convey that there's something unusual happening. And I really like this element, this ground here. I think it's very cool. And what I wanted to show primarily is the idea of layering things on top of each other. Okay, so yeah, I like this. And let's do one more thing. So see this this guy, I'm gonna leave the result. I liked it, but some parts are, where is it? Some parts are actually in the source. They're not moving too fast because after the impact happens, the particle doesn't move too much. So what I'm going to do is I'm going to create a point fob, and I'm going to isolate the points by their speed. Remember, we are left with the velocity. Okay, so see how the velocity vector looks like. And as it gets older and the point gets calmer, the velocity is going to get lower. So I'm going to compute the length of the velocity. I'm going to fit range that, and I'm going to expose these guys because I don't know how much, because I don't know the min and max, so we need to visualize that. And then I'm going to plug this ramp into plug this linear result into a ramp, and I want to colorize the particle based on their speed. And this is how flip fluid creates its look with that blue and white preview. So let's make a dark blue here. Let's make a bright blue and another blue. And maybe this saturated a bit more hue. Okay, and let me change the background to light, turn off this, and let's go back. And you can see the brighter the faster the particle, the brighter it is. And I'm gonna tweak this. Before it was 0 to 1 and everything is white, so I'm gonna say between 5 and 15. If it's faster, then if the speed length between 5 and 15, give me back a linear value. And you can see now we've isolated only the fastest moving part. You can see they're white. I'm gonna set this to red. I'm gonna set everything else to black. I'm gonna remove this color. And if I hit play now, see we've got that nice emission there. Okay, I like this part. What I'm going to do is I'm gonna isolate everything that is red and delete everything else. So at CD, we've done this expression, so let's grab it from here. Okay, cool. We're processing now the collision part and only using these points. Okay, now I'm gonna I like this setup, but I want to add something else to it, so I'm gonna copy it for now. Or you know what, I'm not gonna copy it. I'm gonna connect this here, and I'm gonna copy the source. Yeah, copy the source. Let's move this and use this source instead. So here I'm gonna say I'm gonna leave the velocity to 1. I'm not gonna add any y addition. I'm gonna leave the variation, the birth, etc. to 4, and here all points, all good. Let's hit play. See what we get. We get another layer shooting outward. Now why is it too fast? Not sure why it's too fast. Let's add a huge pulp drag to calm this. So 0.1. Let's see. I liked it before. The force is too strong. It's gonna say this, set this to 3, lower this to 3, set this to 1, lower this to 3, and that's it. Let's hit play. Cool. So the source, actually, I'm not using the correct one. I was using the first input. I'm gonna change it to use second input. Let's hit play. Let's hit play again. And we have a different effects now. So let's set the color to, let's give it a different color. Something like that. And right now, see the points here? There, I don't have a lot of points. And I need to go all the way back to the original sim, increase this, and it's simply a lot of work. So what I'm going to do is I'm going to show you a node called point replicate that can take the existing points and duplicate them. So right now it's making 100 copies per point. So we're going to get 83,000. You can see the shape is a square, is a box. I don't want a box, I want a sphere. I'm going to lower the size of the sphere like that, and I'm going to add a I'm going to add some noise to it. I'm going to increase the frequency of the noise. This will just jitter the points. And another feature that I like is we can stretch these points to match the velocity vector of these points, because this node was built to help with situations like this. So I'm going to say velocity stretch scale, and you can see now we're getting streaks instead, and this is very, very, very cool. And we've increased the point count a lot. We can lower the streaks, we can increase it, and we can change the seat. So let's say 0.5. Okay. If you have a scale attribute, it can also be used to with this. So we have to be careful with this geometry because, again, it's going to multiply everything by 100 times, independent from the input count. So what I'd like to do is I'm going to copy this, gonna plug it back in, and I want to create some nice coloring for this. And I'm gonna set this to white, this to have blue, and this to have a darker blue, and let's set this to 1, this to 10, 25, yeah, something like that. I'm not gonna cache this for now, I think it's gonna be fine. And let's take a look at the result. It's gonna be slow at the beginning, it's gonna emit a lot of points, obviously. Yeah, it's gonna take some time. So let me see. I think if it passed up to here, it's gonna be a lot faster because that's when most of the emission is happening. But again, if we have 300,000 points, that's how much it's gonna emit on that frame. The next frame is gonna emit 300,000 to 100,000. It's gonna be in the million range quickly. So let's middle click on this node, see how much points we have. And see the memory now, it's not fitting this, it's not able to cast this in 5 gigabytes anymore because it's just too much points. Come on. Let's see, let's go back one frame. Yeah, 13 million, definitely a lot. So I'm gonna set this to 10, and I'm going to plug this back in. And what I want to do is I'm gonna connect both of them with a merge node, and see this one called a source first input. I'm gonna call this first source, second source. And see here under stream, it's using this $OS. If I middle click, it's going to resolve to the full name of the node. And that's what the $OS means. That's what the expression will resolve to. I'm going to go up and let's copy. I don't have to copy it. So this is going to import the particle sim. I'm going to turn off caching. I'm going to copy the output, the thing that saves. I'm going to call this dast hit secondary. And with that source, if I middle click, you see here we have 2-point groups. One of them, one for each source. Okay, and I'm going to delete the attributes because it will increase the point count. So not a delete group, attribute delete. And I'm going to delete everything except, let's see. Yeah, I'm going to delete color. I'm going to delete, except V and ID. That's it. I'm going to delete everything else, and we can redo the coloring because it's just based on the velocity. We can redo that. Or no, let's leave it. That's fine. So another thing I want to do is we only have 2 nodes. So if a point is inside this group, it means it's not on the other group. Okay? If it's here, it's not here. So we don't have to keep both of them later. We can say isolate the points that are in group A, and or isolate everything that is not in group A. So we don't have to keep both names. And this will also help with the data. Okay? Secondary, let's call this secondary, save, and we'll continue in the next video. Thank you guys for watching, and see you in a bit.